Okay, the key to this is actually in the title, the zero product property law. That's what I was texting about. If you have two things that are multiplied, they have to be multiplication and they equal zero. One of these to be zero. Either the A is or the B is. And so if you can imagine, like, if it was just like some number three times some number you don't know, let's call it B, so it kind of fits our model, and it equals zero. I don't have to guess what B is. I know what B is because there's only one number you can multiply anything by and get this zero on that side. And so that's the point here. If I have two things multiplied together, it really doesn't matter what the A value is if the B value is equal to a zero. And vice versa. It doesn't really matter what the B value is if the A is zero. Okay. And so if the product is zero, one of these has to equal zero. And so what's important to understand is that it is multiplication. So when you see these two binomials like this, they are like your A is this factor and B is this factor. Remember, factors are things that multiply together. Um, so A and B are factors. This x minus 2, this x plus 5, they are the factors. And so if A times B equals 0, either the A equals 0 or the B does. There's no other way it can give you a product of 0. And so we exploit this idea and we say, well, if the A, but the A remembers this x minus 2 in this case, either the A equals 0 or the B has to equal 0. And these little equations, then we can actually solve to figure out what the x has to be. So I've added 2 to both sides, and then I subtract 5. And so I get x equals negative 5. And those are the two answers. Now, I truly don't know which one it is, but if x is 2, this factor becomes 0. This factor would become a 7. It doesn't really matter that this is a 7 because 0 times 7 is 0. And if I plug in the negative 5 into the first factor, it becomes negative 7. But then the second factor, when I put that negative 5 in there, it becomes 0. And so it becomes 0 times negative 7. It makes it true. And so we just have to make sure it's in this multiplication or factored form. And then we can use this little concept. And that's all there is to it. So here I go. I've got two binomials multiplied together. And this is the one that we see most often. So just get used to that look. And you just take the first factor, you set it equal to 0. You take the second factor, you set it equal to 0, and you just solve those two equations. You just use your standard solving. These are just nice little linear ones. Add your constant to the other side, divide by 7, 1/7. Not a very nice answer, but that's what x could be. And you can see if I put a 1/7 in there, it'd be 7 times 1/7, which is 1. And 1, take away this 1 right there. That gives you 0. Again, I don't care. 1/7 doesn't make this factor 0, but this factor becomes 0, so the product is 0, and it'd be true. The other factor, though, it tells me if I plug in as I solve it here, divide by 2, it tells me, hey, if you plug in a negative 5 halves, I become 0. And so I would make the answer 0 when I multiply. So there's our two answers. That's it. I think you can solve this one right there. Okay, so down here now, these are not in this factored form. And this is why you had, I'm certain, practice with factoring these trinomials. And they should have walked you through the steps where you always check for a GCF first. There wasn't a GCF in here. And then it depends, every teacher does it a little bit different. I teach my students that, hey, when your coefficient is 1 in front, you immediately know these have to be x and x. And then you're just looking for, we call this our A term, our B term, and our C term. You just got to figure out what the numbers are that go here. And the clues are as follows. We call this R and we call this S. The rules or the clues are the R times the S has to equal the C. So for this problem, the R times the S would have to equal 16. So right away, this little clue tells me that the R and the S is either a 1 and a 16, a 2 and an 8, or a 4 times a 4, because those are all the factors of 16. That's stuff you just have to pull out of your head or get out a multiplication table for. So that's the first clue. And that narrows it down to three choices. The second clue, though, that helps me really pinpoint it, is whatever the R and the S are, when I add them together, they have to add up to the B term. So my B in this one is that 10 there. So that for us would have to be a 10. So now I start looking at these pairs right here, and there's no way to add a 1 and a 16 to get it 10, not 0, sorry, 10, 10 right there. So there's no way to add those to get a 10. 2 and 8 are a possibility, though, because if R is a 2 and 8 is an S, or vice versa, those two numbers would add up to 10. And they also multiply to 16, so therefore I know this is a 2 and an 8, and they both are positive, so they add up to that 10. And now that it's factored, now I can use rule zero product property. X plus 2 could equal 0, or the x plus 8 could equal 0. Subtract 2, subtract 2. X is negative 2, subtract 8, subtract 8. X is negative 8. Okay, so hopefully you got this part down. If you're having a hard time with the factoring, I will demonstrate the technique I teach for this one. So in this last problem, there was a 1 out front. In this problem, there's a 3. And the first thing I would do when I see that 3 is say, oh gosh, I hope I can factor a 3 out of everybody, because then I could use this rule over here to factor it. But 11 doesn't have a 3 I can take out, and neither does 4. And they'd both have to have some 3 in there so I could take the 3 out. So I can't use that. So we have to use a modified method of what I used over here. The modified method is as follows. First thing I do is I take A times C, and we usually just put that little number right here. That's going to be a negative 12. And then I do the same thing I did before, except instead of putting X and X like I did over here, I just copy what exactly that A term is here. I just go, okay, 3x and 3x. Now, those two multiply to 9, so that is not my answer. They're not going to be a 3x and a 3x. When these two multiply, they got to give me a 3. But this little method, you just put the 3x into 3x, it'll work itself out in a little bit. And once you do that, it's basically the same rule. The R times S, if you remember, it had to equal C. I don't know why I put a 0 there. I was thinking about the zero product property. That should have been R times S equals C. Hopefully you can track that mistake. And then my C was 16 right there. So normally R times S is C. But when we do it this way, we go R times S has to equal this A times C. So I'm going to write A times C. But for us, that would be negative 12 in this problem. And so again, as soon as I do that little step there, I just make a list of everything that multiplies to 12. Notice I'm not putting the signs on them because it's supposed to be negative 12, and these all multiply to positive 12. But that's all right. When I do my next step, I'll figure out which one is negative. So just like before, R times S had to equal AC instead of just C, and then R plus S still has to equal B. So that's the same rule. Plus S still has to equal B. So now I look at this list. Let's see what my B is, an 11. So I'm going to change that B to an 11 there. And let's see which pair could do it. So 1 and 12 could if the 1 was a negative. Okay. And that might be our answer there because negative 1 plus 12 is 11. So that would work. And negative 1 times 12 is negative 12. So that's the pair we want. I'm going to show you quick why the others wouldn't work. 2 and 6, there's no way to combine those, no matter if they're both positive, negative, or opposite signs to get 11, and the same with 3 and 4. Okay, so you just go through the list, figure out which pair and how you could arrange the negative sign if you need one to get that, and still maintain that it gets that negative 12 when you multiply. All right, so now that I've decided what they are, I just put those in there. I go, okay, a negative 1 and a positive 12. Doesn't matter which side you put them on. But here comes the very last step. Remember, these two have to multiply to give you this 3x squared. Right now, they multiply to give you a 9. But when you use this method, one of these binomials, either this binomial or this one, or both of them, will be divisible by common factor. In this case, this second binomial both terms divisible by 3. And what you do is you just go, okay, I'm going to divide to both by 3, and now I have my answer. 3x minus 1, that's this factor. And this one simplifies to x plus 4. You just toss that 3 away. That 3 is this extra 3 we put in at the beginning. And so it shows up as this extra GCF that can just be taken out. But there's our factorization. And now we just set it equal to 0. And now we can use our 0 product property. So I'll let you solve those to get your final answers. See here, I'm not going to factor that one for you. I'm going to let you, gosh darn it. I probably should factor it for you. This one's weird. Not weird. It's just different because these first two all had 3 terms, 1, 2, and 3. This one only has 2. And when you encounter one like this, it's quadratic. Look for a GCF, just like you always do, because frequently they will have one. Not always, but I shouldn't say that because if it's x squared and x, there's always an x they have in common that you can take out. But the 12 and the 8 usually do as well. In this case, 12 and 8 are both divisible by 4. So you would want to pull a 4 out of those two. And they both have an x. So you want to take out the least exponented x. X to the first is the one they have in common. All right, so these are just little divisions to figure out what's left inside. 12 over 4 is 3. One of the x's would cancel. And then 8 over 4 is 2, and the x's would just cancel. And so this time we factored it, and we can now solve this one. Here's your first factor, okay, 4x. It's not a binomial this time. Here's your second factor, 3x plus 2. And so we can now write 4x equals 0 and 3x plus 2 equals 0, and we could just solve those. 4 times what gives you 0? Think about that for a second. That's that 0 product property in action. There's only one thing you can take a 4 times to get a 0. X could be 0. That's one of your answers. This one you got to do a couple of steps on. All right, so that kind of is it in a nutshell. Factor them, set each factor equal to 0. Um, this first manipulating them so you get one side of the equation equal to 0, that just means get your terms all on the left or right side, and then do exactly what we're doing up here. Factor it and set the factors equal to 0. Okay, so like this one, my first step would be, hey, I got to get the 10x away from this side. So I'd make that 0. And while I'm doing that, I might as well get rid of this 15 as well. And so this right side is 0. The left side is now x squared minus 6x minus 55. And then you'd go about your business of trying to factor that. Frequently, I said R times S equals C. C keeps looking like a 0 on me. Um, Whenever your A value is 1. So you could always take this 1 times negative 55 here, and that just reminds you to always do that. Okay. But this list, back to my point, this list, I made it over here. Lots of times you'll see a teacher put them right underneath here. And then they look for the pair that add up to this -6. You may have to adjust your signs, but I think this 5 and this -11 would add up to that. So that's probably your pair. Once you make that negative. But now you just factor it and set each factor equal to 0, and you'll have your answers. Same deal over here. Drop that little line if you like to. Move your 3x over, so you subtract it both sides. You move the 2, so you add it to get rid of it from the right to make it show up on the left. And then again, you'll have to, no x's. Excellent. Plus 9 equals 0. Oh, you remember this guy? This is the difference of squares. Called that because these are two perfect squares. Teacher probably would have written something like that. If they didn't, they may have taught you, hey, it just factors like all our other ones, which I think is kind of cool. Students don't recognize this lots of times. But we could practice this. This is not the way you would do it, but I want to show you this still works. This is the same thing as like 4x squared plus 0x minus 9 equals 0. And so if I was trying to factor this, just like I did the second one up here, B, I would go A times C, because it's not a 1, it's a 4. That's negative 36. So I'd run off to the side. I say, hey, R times S, you got to equal negative 36. And make a list. 1 times 36, 2 times 18, 3 and 12, 4 and 9, and 6 and 6. And then the R plus S, it has to equal a 0. So right away, I pinpoint this 6 and negative and 6. I'd say, well, they'd equal 0 if one of them was negative. And now I check it and say, well, do they still multiply to this 36? Oh, yeah, now multiplies to negative 36, which is exactly what I needed. I could use my 4x in both opening spots. I'd put 1 6 in here negative, 1 6 in here positive. And I'd go, ooh, there is a GCF in this one. They're both divisible by 2. Oh, there's a GCF in this one. They're both divisible by 2. I could divide that 2 out and just throw it away. And now I've got my factorization. Okay, so that's a long way to do it. We'd rather have you do this by sight and say, hey, the square root of 4 is 2, the square root of x squared is x, square root of 9 is a 3, and one of them is minus and one of them is positive. Okay, so that's a quicker way to do it. But I wanted to show you that you could use that method on it. Just have to have a b term of 0 in there to remind yourself. Okay, set each factor equal to 0 and solve those then. Right, you got to do that last step. Don't forget that. That's our goal, to solve and find out what x is. Um, solve the system. This one, notice they're both set equal to y. So you can set these two equations equal to each other. And now it's just one big equation, and the directions are solve it. Well, how do we solve it? Well, these are quadratic, and so we solve it just like up here. You got to get it equal to 0, then you can factor it, then you can solve it by setting your factors equal to 0. Right, so this would take a lot of getting, stuff lined up first. Have to get rid of that from the right. You'd have to get rid of your 10x from the right. You can do these all at once rather than separate steps. You have to get rid of the 4 on the right. Each time I do something to the right, I'm doing it to the left to keep my equation nice and balanced. And now I'd be off to the races trying to factor this. Um, and again, there's that 4 times 6, so you'd have to try and get a 24 from that product. Again, remember, start with 4x and 4x. I'll let you try and work that thing out. Here's a B. This one's a little bit tougher. I'm not sure how he'd want you to do this. Um, well, here's the way I do it. Now that I look at it, there's a lot of options here. Um, but the one I see that I think he wants you to exploit is the fact that these both equal 5. And therefore, this thing right there, this expression is equal to 5. This expression is equal to 5. So these two expressions are equal to each other. We don't even have to write down anything about the 5. We just know that the equations equal each other because they both equal the same number. Oops, there's 12t minus h. Make sure I can distinguish my t's. Uh, and again, we just get this thing equal to 0. Now, there is this negative 16t squared. So sometimes teachers would tell you to, hey, move everything to the right. I'm not sure I would do that in this problem. I think I would do this. So got to get this right side equal to 0. So I start moving stuff over by adding the opposite. There you go. I'm going to add an h, and I'll add an h to the other side. Oh, this is going to come out really nice, I think. See here, that's going to give you a what, 64t, I think. The h is here canceled, which is kind of nice. And now we get 0 on the right hand side. Uh, so this is very similar to a problem we were talking about earlier up here at the top. Very similar to this one that only had two terms in it, and we could take a GCF out. This one's only got two terms as well, and we could just take a GCF out. However, I want to point this out. It is better than just taking a GCF out because this is an equation. It has, in other words, it's equal to something. We're allowed to do anything to this side that we want to, except for things like divide by zero or multiply by zero. But we can basically do anything to this side that we want to, as long as we do it to this side. So rather than take the GCF out and pull it out front, what we could do is just, hey, I know that -16 is divisible by -16. And I happen to know that 64 is also divisible by 16. Uh, so what we would do here is divide this side by 16, this side by 16, and this side by 16, or -16. And I want the negative because now I get a lead that is +1 instead of a -1. This becomes -4t equals 0. 64 divided by 16 is 4. And so now I would GCF it. And I start my GCFs by looking for a number, but there is no number to take out. Then I check my variables. They have a t in common. So I can take the t out, just divide by t. So it reduces it by 1, divide by t. So the t's are gone. And there's my two answers, or my two factors that give me my two answers. I always love it when a T or an X pops out, because when an X is out front or a T's out front, 0 is immediately an answer. The other one you still have to solve. Take the 4 to the other side, so T equals 4. Oh, there it is. Okay. I think that's everything except for this one here. I divided by 16. I take out the 16. I didn't pull it out like a GCF. I want to go back up to this one. This one right here originally was 12x squared plus 8x equals 0. So this one, I was trying to emphasize the GCF part, but you could have divided everybody by 4 at the very beginning, which would have yielded this, and then, oops, there's an x right there. And then I would have taken out the x, leaving me 3x plus 2, and I'd have exactly the same solutions that I had gotten here in pink. Divide by 4, you get 0. And this one you solve, and that one you solve. It's the same thing. So I could have done that, just divide by 4, gotten rid of that uh, number in the problem. All right, I'm going to skip the one that says don't do. Find x-intercepts of each quadratic function below. That's what you've been doing over here. All right. Um, So in this equation, you found out, hey, when x is 2, the answer comes out to 0. So if this was like a function equals x squared plus 10x plus 16, what you just found out is when you substitute in a -2, this thing comes out to be a 0. So it's like an ordered pair. Hey, when x is -2, the y value is 0. Hey, when x is -8, the y value is 0. Okay. So when they say find the x-intercepts on these problems, if I can find my problems again, what they're saying is, hey, find out when the y is equal to 0. So, hey, when does x squared minus 81 equal 0? And then you go about your business, because this is quadratic, of trying to factor it. And I won't tell you how to factor that one, except I will tell you that is a difference of squares. To see if you can figure out how to factor that and then solve it. Okay. See, same thing. There's our y. We want to find out when it equals 0. Remember, they're asking for x-intercepts. So x-intercepts are where it crosses the x-axis, and they always have some x coordinate, but their y value is always 0. So that's all we're doing here. We're saying, hey, what gives this a y value of 0? Okay. That's an x squared. Must be getting late. And let's see here. Ooh, 12 and 18, both divisible by 2. We do that first. I think I could have gone bigger than that. 6x squared minus 9x equals 0. Yes, I could have, because 6 and 9 are both divisible by 3. I'm going to keep on going. Get this thing as small as you can before you start factoring it. Makes life easier. There we go. We'll create your x right there. And then I'd look for a GCF, and I've taken care of the numbers, so I'm looking for that variable. Yeah, the x comes out. There we go. That x, there he is, gives me 0 for an answer. Then you got to solve that guy. You get the idea, I think. So this one, hey, y equals 0 is what we're looking for. This one, I would divide everybody by 2, and now try to factor it. Smaller numbers, right? This is super beneficial. If I leave the 2, I got to do that a times c method. But since everybody divides by 2, now I just have a 1 there, and so it's easier to factor. Quadratic function is graphed at right. What are the x-intercepts? Oh, you know those guys. There they are, right there and right there. Those are your x-intercepts. Find their coordinates. There's your origin. 3, that's 4, 0, x-intercepts. Okay, I'll let you find the coordinates of that one. Of this one rather. Based on your answer to part A, what two factors must be part of the factorization of this quadratic? Okay, so this is really a key thing here. 1, 2, 3, 4. We got one of these at 4, 0. The other one's over here at -1, -2, it looks like. -2, 0. That means these are the x values that make this some equation, some quadratic equation equal to 0. Now, if you've been watching these at all, let's jump up here and you'll see. Notice when this is x minus 2, I get a positive 2. When this is x plus 5, I get a negative 5. And so we could actually work these problems a little bit backwards, and we can figure out exactly what the factors were. So if this is let's start with the 4, it's easier to understand. If that's my solution, what has to be the factor here that gives me that answer? So basically, I want x to equal a -4, but if I add 4 to both sides, I get x plus 4 equals 0. That's this factor, but it's not that factor. I wanted x to give me a positive 4, sorry. I want x to be a positive 4, so I subtract 4, and I get the factor x minus 4. And I knew that was wrong right as soon as I wrote it, because this is always just the opposite sign. It's always x minus your solution. And x minus your solution has to be adhered to, because when I write my next one, x minus, what's my solution? -2. So the actual factors are x minus 4 and x plus 2. And again, it's kind of this opposite sign rule. X plus 2 gives me the solution -2. Okay. So keep that in mind. Always x minus solution, x minus solution, and you'll get your factors correct. I hope that helps you out, and I will post this as soon as I can.